All right.
Hey, Nelson. What's up? Oh, nothing, just webinaring. Wicked excited for this one. Okay, and normally I say we're going to give people a couple more minutes to hop on, but it seems like people are hopping on and they're super excited. So let's just start.
All right.
Um, so the how we got here today, right? I had done some network analysis way back in 2013, and it was in Python. It was for a diabetes use case, and I was doing a lot of manual stemming, which I know like isn't even the way people do it anymore. And then I used this, after using SQL and Python, then I went to another tool. It's a free tool, but it's called Node XL, and it allows you to create network graphs. And I was just aware that the ability to do network analysis has come a long way. Just like everything else in data science, the packages that are allowing us to do these things are a lot more intuitive. They're creating a lot prettier graphs nowadays. And I knew that Matt had created a learning lab around network analysis. And so when I reached out to ask him about, what he had put together, we decided that it would be best if, instead of him just sharing with me, let's share with everyone, let's make it fun. And then he recently just launched a 4th course. So of course we're gonna do a promo where we're offering 20% off of Matt's courses until Friday. So everything's super exciting. And, but so for the majority, I'm gonna let Matt take it away, and he'll be doing a demo of his code that he put together, and I'm super excited to see it.
All right. Thanks so much, Kristen. It's great to be back too. This is one of those, yes, it's a learning lab that I did here, a couple of weeks ago. It's actually been one of the most well-received learning labs too. So it's super exciting. It's network analysis, but I think the cool part about it is the business problem that we solve and how we utilize network analysis to really focus on viral marketing, which is being able to target the most influential customers in a data set, being able to identify them, and then really being able to explain why they're the most influential. So, all right, with that, I'm going to share my screen. Kristen, just do me a favor. Let me know if everything looks good, and then we can get started.
Yep, perfect.
Okay, you can see it. Cool. So yeah, again, this is network analysis. It's one of our best performing learning labs. It's something I did a couple of weeks ago, and it just really got some great feedback. And it's really, I think, a credit to this idea of the business case that's so useful for everyone, which is to be able to look through a customer data set and be able to identify the most influential customers so you can develop products and services specifically for them. Okay. So before I get started, I do want to just kind of go over the general structure of the webinar. We're going to do about 20 minutes of presentation, and that's just going to be like the minimum, what I call the 80-20 concepts, the minimum concepts that you need to know in order to be able to get into the demo and understand what's going on. So this is things like talking about network analysis, talking about the types of software we're going to be using. So that'll take about 20 minutes. And then we'll get into the fun stuff, which is the code, and that's going to be really exciting. You're going to see 2 of my favorite packages, tidygraph and gggraph, that are used for network analysis. And then what we'll do is we'll wrap up at the end with some pro tips. So stick around. I've got some really cool pro tips on what you should do in order to be able to really make network analysis an effective part of your customer database analyses. Kristen, I know you introduced yourself a little bit. Is there anything else that you want to say?
Yeah, so for everyone who's here who doesn't know me, I'm Kristen Kerrer. I've been a data scientist. I was in corporate for 10 years, working across the utility industry, spent some time in healthcare, and then the majority of it was in e-commerce. I've worked on a ton of cool projects. Nowadays, I own my own, I have my own consulting business in data science, and and I enjoy doing webinars with Matt Danchow.
And I'm calling this the dream team. I love being back because, I did a little bit of math, and we've got 20 plus years of experience, just data science experience with me and Kristen on the phone here. So definitely, this is the type of thing. At the end, we're going to have time for questions. If you have any questions, we'll go through them, and it's your chance to ask the experts. Just a little bit about myself. If you don't know me, I'm the founder of a company called Business Science. I operate an online learning platform. We just launched our 4th course. I'm super excited about that, but what really drives me is being able to help you succeed in data science. That's my passion. I want my students to be able to not only get jobs, but able to accelerate their career, get promoted, get promotion after promotion after promotion, and honestly just be able to do great things for their organizations that they work for. I do have a little bit of background in consulting. I'm also an instructor, and really kind of I think what sets Kristen and I apart is that we're about business results first, and then using data science to be able to get those results. So that's why I say we're kind of the dream team, the business gurus. All right. So with that said, the agenda for today, I already kind of said this. We're going to have a business case study. So we're really going to be talking about a business problem. It's applicable to any company because all companies have customers, and what we're going to be doing is analyzing that customer base. So we've got customer credit card history from each of these customers. They're bank customers and they've been given credit cards, and we're going to be able to mine their payment history for interesting trends, relationships, and actually develop networks. And that's what you kind of see over here. This is an example of a network visualization. We are going to talk about network analysis. That's the main focus of this. It's really about viral marketing, but we're going to use a specific set of tools called network analysis to help us understand our customers a little better. So we're going to talk a little bit about network analysis, the key concepts, the R packages that allow us to do network analysis, and then we'll jump into the 30-minute demo. It's like 300 lines of code, so it's definitely going to be pushing 30 minutes, maybe even a little beyond that. But after that's done, I definitely want you to stick around because we've got some pro tips for you. And those pro tips are going to be key. It's going to give you the recipe that you need to implement in order to be able to take what you learned today and be able to get value out of your organization. Okay. So we're moving on to our business case here. It's customer communities. And the key here is that we all need to understand is that every customer base, it doesn't matter if you're working for a bank or healthcare or whatever, these customers, these users of those products, naturally they form communities, and it's just a natural phenomenon. And it's a really useful thing because what we can do is we can mine our data set and understand those patterns that those customers are doing. And what's really cool is, and the key concept behind network analysis is it's all about influencers. So if you've heard of like social network analysis, like taking Facebook and, analyzing who's connected to the most people and who's this and that, that's what we call influencers. So the more people that are connected to other people, the more connections that they have, that kind of elevates them. So if you develop a product specifically for that person that is connected to a bunch of people, then what tends to happen is you can avoid the trap of trying to appease everybody and produce a product for everybody, and really focus on certain customers that you want to target, and those products will spread like wildfire. So that's what we call viral marketing. It's the ability to customize products and services for specific groups that are in our data set, and not try and target everybody, but avoid the trap of trying to do a one size fits all, and really develop customized solutions for those particular influencers in your database. Okay, so that's a little bit of the background. The data set that we're going to be dealing with today, we've got some information on customer history. So if you think of the data set like a spreadsheet, you can see that each row is a customer. So we've got a customer ID here, and that's what we're seeing. And then we have information on each of those customers. So this is credit card payments. We know their monthly balance, the frequency that they have a balance each month. We know the value of their purchases, one-off purchases, what's the dollar value of that. So we have all of these descriptive features that really characterize the behavior of those customers when it comes to utilizing that credit card. So that's what we're going to mine for trends, and I'm going to show you how to identify your entire customer network using a data set like this. Okay, but before we can do that, we got to do a little bit of homework. We got to go through some studies. I'm going to give you the minimum that you need to know in order to be able to understand what's going on with network analysis. So these are what I call the 80-20 concepts, the 20% of concepts that gets you 80% of your results. So first thing that you need to understand, there are two types of network analysis. So you often hear people talk about network analysis. Normally what they're doing is they're referring to this type of network analysis where you're taking a massive data set and you're trying to understand where the customer groups are located. And that's what we call undirected, meaning that there's no kind of hierarchical relationship. It's just, one customer is connected to another customer because they purchase similar products and they tend to do things similarly. So kind of the thing that you want to think about there is, all right, what clusters are in my data set? What kind of groups are starting to form? And that's the value that you get out of doing this type of network analysis. Now, there is a second type of network analysis, and that's what we call directed. So if you think of like an organizational chart, or if you think about, this is what's called a tree map. So that is where you have an actual hierarchical relationship where there might be a top level, all customers or all these might be different departments in your organization, and then within departments you have a sub department like sales and marketing and so on, and then you have the people that are within those departments, and maybe you have like the just different attributes about them. So that's what you get out of the second type of analysis. We are not going to be focusing on that today though, so that's the last I'm going to mention about it. We are going to be focusing on this one because this really allows us to mine for customer trends. Okay. Some core concepts, again, 80-20. So what we're going to be doing today is really focusing on the process to go from raw data to an actual solution using network analysis. And one of the key concepts that you need to understand is there's this thing called an adjacency matrix. And what that is it takes each of these customers. So we've got our customer data set right here at the top. And what we want to do is we want to convert that in this thing called an adjacency matrix, where we have customers here and we also have customers here. And then we have a value that represents the relationship, how strongly associated those two customers are from each other. And you can see this, it looks a lot like a correlation matrix. And that's what tends to happen. You can see that here's a 1 is going to be the highest correlation that you can have, and that's one customer to another to the same customer is always 1, but that's not really an interesting relationship. What we want to do is we want to understand what customers have a that are not the same customer, but which other customers are all related to each other. So the key concept here is that we've got an n by n matrix, and that value that's in there is the relationship strength. So that's all an adjacency matrix is. Just 2 dimensions, customers and customers, and then some sort of value in there that represents the strength of relationship. Okay. All right. So if you understand the adjacency matrix, the way that we showcase the adjacency matrix is normally by doing some sort of visualization, because what we're trying to do is understand, okay, out of that entire adjacency matrix, which customers are all connected to each other. And that's what this allows us to do. So this type of diagram is represents the output of some software that I'll talk about here in a minute. It's called gggraph. And what it does is it makes these network visualizations. And you can see each one of these visualizations has these groups of these lumps or clusters of people. And these are all customers in our data set. The these little dots are what's called nodes. So those are akin to customers. And then the edges are the relationship strength. So that's what all of these edges are. And you'll see that some of these groups are disconnected. And that's because, and I'll talk about this in a minute, it's because we've pruned them to only expose the most important relationships. Okay. So in this visualization, we've got nodes. So this is a node. We've got edges, and this is the relationship. So we got customer as a node to this customer, and then this is the strength. They have a line here connected because they have a strong relationship. And then when you get a bunch of these customers together and they're all connected, they form what's called a cluster or a group. And the nice thing about this is these are the most important groups because these are those with the highest relationship to each other. Okay. All right. So I mentioned on the last slide a little bit about pruning. This is the concept that, and this is really where the data scientist comes in. And we want to develop these visualizations to locate the groups, but we want to have a visualization that is somewhere between these two here. So this one, you can't see any groups. There's nothing, it's the threshold that we're using to identify groups is way too high. And this visualization is the opposite case. We're starting to get too low on our threshold, and we're starting to see, a bunch of different groups form. Well, that's not going to be good, because then if we have too many groups, then we're going to try and develop products for too many different populations. So what you want is something down here that looks like this, where you have, a nice dense cluster here that we can focus on, and maybe another one here that we can focus on. So you're not trying to, cover too many different groups. The key concept, so how we get between these two, it's what's called pruning. And I'll explain this when we get into the code and actually show you how we do it. But what we're trying to do is trying to take that relationship and just kind of get, a couple of different clusters starting to form. It is subjective, so it's part of the data scientist's job to be able to determine, to look at these visualizations and decide what that cutoff is. Okay, so we talked a lot about network analysis, the concepts and the theory. But now what we want to talk about is the software that we're going to use to implement it. So the first software we're going to use is this thing called tidygraph. How many of you are familiar with dplyr in the tidyverse? Probably most of you, right? If you've used R, okay. So what dplyr does for data manipulation in the tidyverse, tidygraph does for data manipulation with graph data. So what tidygraph does is it actually makes, it's two data sets in one. The first data set is what we call nodes, and these are, you can think of these like labels. So this is 1, 2, 3, 4, and the label is the C102. That's the customer's unique identifier. Well, anytime you see a 1 here to 711, so this 1 is this first customer, and then the 2 is the 711th customer in this node data set. And then that strength of that relationship here is represented as this weight. So 0.996, those are two highly related customers. So it's got the node data set and it's got our edge data set all in one kind of structure. So think of it just like two data frames that's captured in this thing called a Tibble graph. So it combines node and edge data inside one tidygraph object. So when I say Tibble graph, I just mean tidygraph object, and I'm going to use those terms interchangeably. It makes it super easy to work with network data, so we can just do what's called activate, and we can say activate edge data, and then it'll give us access to that data frame, and then if we want to add another column onto it for like plotting purposes or something down the road. And then what's really cool is we can apply these special network analysis functions like group components, which will identify, your top N groups for you, centrality degree, which gives you the number of node connections in your data set to say like this customer here, and then you can rank them to expose the most influential customers. So it's really powerful stuff. And then gggraph is the same thing. So what tidygraph was, or what dplyr and tidygraph are for the data manipulation side of it, gggraph is like ggplot for, for network data, for tibble graph data. So it allows you to very easily make these types of visualizations that you can put in presentations, and then that you can also use to be able to like highlight different groups in your customer data set. So if you're familiar with ggplot, it kind of follows that same format where you've got a gggraph object here. This is like the ggplot function, and then you add these geometries, and then you can add a theme and so on. Okay, so we're going to use that software here in a minute. What we're going to do is, again, this is kind of like a full process that we're going to go through. So the workflow that we're going to go through once we get to the code, we're going to be using, doing a little bit of data cleaning and transforming and visualization at first, just to explore the data set, do a little EDA, correct some missing values, and then get that data prepared so that way we can then do our network analysis. In step 2, what we're going to do is we're going to modify that data set. Once we've got it cleaned, that customer data set, we got to convert it to an adjacency matrix, and then we're going to use tidygraph and gggraph to be able to visualize it and identify the most influential customers, and also identify just be able to visualize the most influential groups too, the ones that have the most people interconnected. And then step 3 here, and this is kind of a bonus, but this is something that I teach in my courses. It's H2O and Lime. Then we're going to show how we can explain why certain customers are in certain groups. And that's really the key here is you can develop really customized solutions if you can make that explanation. All right. With that said, I'm going to get into the 30-minute demo. I'm actually going to take a sip of water here, and then we'll hop right into it. Anything you want to say, Kristen?
No, I'm just excited to see the code.
All right, me too. This was mind-blowing when I put this together, and I was like, holy crap, this is like really amazing stuff that we can do with the power of network analysis, and then combining it with machine learning too. So
are you actually using tidyquant, or do you just put that in all of your code?
I use tidyquant just for some of the visualizations. A lot of times I'll use like the theme _TQ. That's this package here. We aren't using like any of the financial analysis capabilities though, which is really what most people use it for.
I just didn't know if you like to add it to all your code, so you could be like, oh, hey, I'm the tidyquant author.
Yeah, it is. So I do add it to all of my code, but it's like kind of out of force of habit.
Yep.
But it's, I just love the tidyquant theme. I mean, it's something that I use for all of my business graphs. So, all right, get started here. We've got tidyverse, tidyquant. We're going to load those 2 packages. These kind of load in the core packages. So you see, if I scroll up here, we're loading in ggplot2, tibble, tidier, and that's what comes in when you do this library tidyverse. It loads all of these R packages here behind the scenes. Tidyquant, that is my R package, and I'm not trying to force you into using it, but I do love the theme TQ, theme _TQ. Anyone taking my courses, which Kristen knows this, I'm always plotting with theme TQ. Libraries for EDA, I'm going to load in the Data Explorer library and also my correlation funnel package, which I think is an innovative way to really just understand kind of at a high level what the features are in your data set and how much correlation there is to some sort of key variable. For pre-processing, I'm going to load in recipes. And then for the last so we got tidygraph and gggraph, and these are kind of like the main packages for doing the network analysis. Okay, so once I got those libraries open and loaded, what I'm going to do is I'm going to load the credit card data. So that's in this data set here in my files. I'm just going to pull this CSV in. So that's what I'm doing here. And then we can see that it's loaded into my global environment and it's parsed the different columns. And if I want to take a look at that data set, it looks something like this, where we've got that customer ID and then we've got all of the attributes that are related. Now, there are 18 different columns. So if we want to see that kind of in a different view, we can stack them all on top of each other like this. So this shows the customer ID, the balance, and these are all of the columns that we'll be using. So this is, again, all information that describes each one of those customers. Okay, so the first thing we're going to do in this section here on EDA is we're going to take a look at missing values. That's what I always do. First is just try to understand how clean my data is. I can see here there's 2 columns, so most of the columns it's pretty clean. Credit limit does have 0.01% missing value, and then minimum payments has 3.5% missing values, so about a little over 300 missing values. So we'll want to correct those before we start moving on. The first thing I'm going to do is I'm going to take this credit card tibble, and I'm going to take a look at this minimum payments variable. And what I'm going to do is just kind of try and understand, kind of what the distribution is of it. I can see here that the lowest distribution is a 0.19. So what that tells me is I can't just replace those values with 0, or I shouldn't just replace them with zeros. What I should do is probably use some sort of different imputation strategy. And I can see that then so the first quartile here is between 0.19 and 169, and then so on. So it just gives me a kind of a rough idea of how that variable stacks up in terms of a distribution. Next thing I'm going to do is I'm going to just isolate the non-missing, and I'm going to run my correlation funnel on it. So you can't run correlation funnel with any missing data. So I'm selecting all of the variables. Let's see, credit card data, Tibble. I'm selecting only the columns that are numeric. I'm filtering where there's no missing values in minimum payments or credit limit. And what I'm going to try and do is, so if I run this, this is basically going to drop this, I'm not sure why it's not scrolling up, the customer ID column. So this is a character. So all the other variables are numeric. So I'm just selecting the numeric variables, and then I'm going to run them through the correlation funnel. So that's what I'm doing right here. And just so this makes sense, if you see, like I'm running it through this first function called Binarize. What that does is it makes bins out of all of the numeric columns. And then what I'm doing is I'm focusing in on minimum payments underscore 825 to infinity. And what I want to do is I want to understand, okay, I know missing payments has missing data in it. So I want to understand which features, if any, are correlated to that minimum payment. So I can then visualize how that missing data should be imputed. So I can see here when I just isolate that top bin of minimum payment, and what I do is I run it through this function called correlate, and then I do the plot of the funnel. I can see that the highest correlation is between balance and minimum payment. And then there's also a little bit of correlation here between cash advance transaction, and so on. So the last thing I want to do before I move on with the minimum payments is I just kind of want to visualize it. And I'm using ggplot here, and I can definitely see that there's some structure to this. I can see that as balance increase, minimum payments tends to increase. And then there's a few, obviously some outliers here, but it's generally speaking a relatively linear relationship. Okay, so that gives me a little information that I can move on into once I get into my imputation. The next thing I'm going to do the same exact thing for credit limit, so I can understand kind of what I should do here. And I can't just impute by replacing 0 because I see my lowest value is 50. So I should not just do like try and replace any NAs with 0. What I should do is try and use a better imputation strategy. Do the same process here with binarizing and correlating. So this time I'm swapping out this minimum payments up here, this bin 825 to infinity, for this credit limit 65,000 to infinity. And I can see here that credit limit and balance have the highest relationship. So I'm going to take a look at how those two stack up together. When I run that, again, there seems to be some relationship going on. As credit limit increase, balance tends to increase, or vice versa. So I definitely see that there's some structure to it, and that gives me a good idea that I can impute. So the next step, so now that I know a little bit about my data set and kind of what's going on, what I want to do is I want to prepare it for that adjacency matrix. So that's my goal, is to get that adjacency matrix. So I need to take and build a recipe. So I'm going to use this package called recipes. I'm going to first impute. And what that does is it just kind of adds a step. So if you think about this like a step-by-step process, I'm going to add a first step to bag impute, minimum payments, and credit limit to get rid of those NA values. And then what I'm going to do is I'm going to take all of my predictors that are numeric, and I'm going to center and scale them. And that's very important because it'll throw off the correlations if they're not centered and scaled. And then the last thing is once I have this recipe, I prepare it. So I'm just going to run this. And what that does is it creates a recipe. I haven't actually changed any data yet, so it's still running. That bag impute takes a little bit of time. So we can see that there's a bag tree imputation, centering and scaling. So it's got each of those steps in there now. So now what I do when I'm ready to apply it to my data set, so this is what my data set looks like. And now what I'm going to do is I'm going to use this bake function, and that's going to allow me to convert this into a data set that's ready for the adjacency matrix. So if I take a look at that training table now, it looks something like this, where everything's centered and scaled and all the missing values are taken care of. Now I still have this customer ID column, and we're going to utilize that as kind of as part of the adjacency matrix when we compare everything to each other. So to make the adjacency matrix, that's what we're going to talk about next. So I kind of went through fast the EDA because I really want to focus on the core of this, which is the adjacency matrix. Make sure you get that because this is a key concept, and then that's going to set you up to be able to do your network analysis. So the adjacency matrix, we start with our training data set that has been modified and pre-processed, and everything's been centered and scaled and all the missing values are taken care of. And then what we want to do is we want to transpose it so that way if I just run this, we've got customer ID and feature kind of next to each other. And then what we're going to do is do another spread operation. So this is basically finishing that transposition. So we're basically taking that where these used to be the rows, they're now the columns, and the features are now the rows. So once you have it in that format, then we're going to drop the feature column. And then, so now I just have columns of each customer, and each row is each one of the features, and I drop that feature column. And then we're going to convert it to a matrix and then run correlation function on it. So when I do that, this will take just a second. We now have a correlation matrix. So this is not a data frame anymore. It's actually a matrix. And I can see that it's a matrix here. And you can see that it's right here, a large matrix, 612 megabytes. So it's got a lot of information in there for us to mine. What I'm going to do is just quickly convert it into a tibble so we can visualize it. And this is what that looks like, where I've got a customer ID and a customer ID, and you can see it's got ones on the diagonal. So that value in there is the strength of the relationship, and how I got that value in there is because I did a correlation between all of the different customers. Okay. All right. So we're now most of the way through the adjacency matrix. What we need to do, we need to next prune the adjacency matrix. So this is the trickiness. The first thing that we're going to do is we're going to get rid of any of these where we have ones in here in this diagonal. So I'm going to use the diag function and just set that to 0. So when I run that operation, now what it does is it converts all of those diagonals to zeros, because we don't want that to show up in our network analysis. It's not going to be useful information. The next thing is that we're going to remove any of the duplicate relationships. So this is a correlation. So the top triangle here is the same as the bottom triangle. So we only need one of those triangles. So what I'm electing to do is take the upper triangle and just convert all of those to zeros. So that's what I'm doing here. Takes a second. And now we've got zeros in the upper triangle. Okay. So we've removed the diagonal and the upper triangle. So now we have unique relationships. And what I'm going to do next is what's called pruning. I'm going to set an edge limit, and I'm just arbitrarily picking a value, something relatively high, because I don't want a whole lot of relationships to be shown, only the top relationships when I do my visualization. So I'm going to do 0.99, and then I'm going to set anything that is in my matrix that has less than that edge limit. I'm going to set it to 0, so that way it doesn't show up in my visualization. So now it actually is mostly zeros in this matrix. And if I run this, I can see the total number of relationships that are remaining. So out of 8,950 by 8,951, there are only 10,000 relationships, almost 11,000. So just under 11,000 relationships remaining, which is not very many considering there's, n times n. So n squared, which is out of 8,940 connections squared, which is 800,000 connections. There's less than 10,000 or less than 11,000 remaining. So that's a good thing, because we've now pruned it and only the highest relationships are remaining. Okay. All right. The last thing I'm doing here, let's see, what did I run? Filter the relationships. So I'm just basically taking this data set, and instead of being 8,000 rows by 8,000 columns, I'm trying to pare it down. So that's what I'm doing here. And when I run this next, I can see that the dimensions have been reduced from, they were 8,950 by 8,951, and they're now 1992 by 1991. And then we can see some of the relationships starting to pop out. So what happens is that I've filtered down so that way each of these columns has to contain a relationship. And that just makes it easier to work with the data set. So when we start doing some manipulations here, I'm going to take that customer correlation matrix and I'm going to convert it to a tibble first. So it just looks something like this, where I have from now as the customer name. I'm going to gather, and now it's in that from and to and a weight column. And then what I'm doing is I'm filtering out anywhere that the weight is 0, because that doesn't matter. We don't need any weights that are, or excuse me, I'm filtering to anywhere that the weights are greater than 0. So I don't want any relationships. I don't want any from twos in my network that are zeros. Okay. And this is the final customer relationship tibble. Now notice that this is still a tibble. We've got our 10,000 relationships in here. And basically what it is it's from some customer to some other customer. And it's got that correlation, that relationship between all the different features, how strong that relationship is. Okay. So this next section, section 7, what we're doing is we're doing all of this kind of pre-processing for the adjacency matrix, and we're just lumping it into a function. So I can take a correlation matrix, an edge limit, and it'll automatically calculate that for me. So it's just kind of a helper function. It's called prep core matrix for tibble graph, and you can see that's doing the diagonal to 0, the upper triangle to 0, doing the filtering on the edge limit, and then it's going to filter any of the columns that are non-zero, and so on. So if I take my correlation matrix, which is a matrix, and an edge limit of 0.999, I can now just automatically detect all of the relationships. And if I adjust this value now, so I decrease the edge limit, so we're going to get more connections now. I can see that now I've got 7,000, and I can make it much tighter. So if I do 0.999 for the threshold, I only get 41 connections. Okay. So this is going to help me when it comes to plotting, And when it comes to pruning, because I'm going to be able to iteratively make these network visualizations, and I'm going to be able to tweak that edge limit, which is the kind of the subjective part where the data scientist has to be able to review that network visualization to decide what the appropriate edge limit is that we should use. All right, so next what we're going to do is we've got this prep core matrix. It looks like from, to, and wait. And then all I have to do to convert it to a tibble graph object is pass it to this as tibble graph function and select directed equals false. So remember, directed is if it's a hierarchical relationship, you set that to true. If it's not a hierarchical relationship, set it to false. So when we do that, it converts it into this tibble graph object, and it's now got a node data and it's got an edge data. So think of the nodes as the labels and think of the edges as the from, to, and wait. So this is what we had before where it was from, to, wait. All it does is it replaces from and to with kind of a unique identifier here, and it maps to this node data set. Okay, so 2 data sets in one, and that's how we work with tibble graph. The next part is I'm just making a visualization now. So I'm going to convert it into a gggraph. I'm going to add a geom edge link, which is kind of like a geom line connecting all of the edge, all of the points together that are connected. And then geom node point, which is like geom point, which is like for scatter plots and ggplot. So when I start doing that, if I run this, it's really cool. It adds edges and it adds nodes between all of the different points, and we get a visualization. It'll take a second. Looks something like this. Okay. And what we can do is we can adjust that edge limit. So 0.996, I may want to increase that a little bit. And we can kind of fine tune this visualization to get it to the point where we want. It will take a little bit longer now since I'm increasing the number of nodes by dropping that edge limit down. But and that's the other thing that you'll want to watch out for is it could, if you drop this too low, it'll take forever to plot because there'll just be too many points. All right, should go here in a second. Okay, so so this is way too many. This is way too many. You've got too many clusters in here. So we definitely want to increase that back. So I'm going to use 0.997 as what I go with. So when I run this, and I'm just going to save it as a tibble graph object, and this is what that tibble graph looks like. So I'm going to have 889 different nodes, so 889 customers that I'm focusing in on as my most influential network. And then there's 1,500 kind of connections, 1,500 links between each of those. Okay. So yeah, once I have that tibble graph, I'm ready to rock and roll. I can do some really cool things, and we're going to go through some of the tibble graph features. So what I found really amazingly powerful is you can do things to some of the different nodes. So this idea of network analysis, there's kind of groups of techniques and there's a lot of different techniques out there that are used. I'm just going to go through some of the ones that I found interesting. One of the things that you can do is you can rank your nodes by the different traits. So there's this thing called node rank traveler. So think of that as like how far can that person travel, but between all of these different links, these interconnections. So that's one of the measures of different nodes and how popular that node is. So the top ranked node, meaning they can travel the farthest between links, is this customer C12967. So that's kind of like a measure of popularity. The measure of popularity, however, that I like the most is this thing called centrality degree. And what that does is it measures how many connections are incoming into that node. So the idea here is it's like the social network analysis, right? So you're on Facebook, you've got 150,000 friends or whatever they're called on Facebook, And so you're like the most popular, right? So ideally, you'd want that person to post one of your blog posts because that's going to get the most network appeal. So that's kind of like what the centrality degree measures. What I'm going to do right here is just run that, and I can see that the top network connection is this C18341. They have 37 connections. So that means that that person is the most popular. And what we would want to do in our analysis is really target that customer specifically to develop a product for them, because if we do that, then that's going to increase our chances of viral marketing effects, which is, you know, if that person starts using our product, or if you develop it because, you know, they have the most customers that are around them that are the highest likelihood of also adopting that product. Okay. So that's viral marketing 101 right there. Just develop a product for your most popular customer. The next section here, you can do what's called grouping. So grouping nodes is also is very similar to clustering. However, it's a little bit, what grouping does is it takes all of the connections and it kind of groups all of them together. So you can, if I run this section of code here, and then what I'm doing is I'm adding the centrality degree, and then I'm using this function called group components. And what it's going to do is it creates a group value for each of these. So remember, this is by the number of centrality degree. So 37 is the most popular, 26 is the next most popular, and so on. These people are all in group 1. So that's what this group components does. And then what I'm doing down here is I'm saying, okay, I only want the top 5 groups, because what it's going to try and do is group everybody together. But you don't want everyone grouped. You want to just kind of limit it to like your top 5 groups or top 3 groups, and then everyone else kind of gets lumped together. So what that allows me to do is to make a graph that looks like this, where I can start to visualize how those customer groupings are working. And so I get a group that looks like this, where I got, this is my group 1 here. I can see that that's blue. And see, hey, this is where that tidyquant package comes into play too, Kristen. So scale color TQ, that's a tidyquant function. That's making it this nice blue, light blue, and red color. So that's why I love tidyquant. Very versatile. All right, so getting back to this visualization, this is exactly what we want to do. We want to have each of these groups identified, and that's what this function here, group components, did for me. And then I also know who the most popular is because of the centrality degree function. And that's really the idea of, if you understand how to use these 2 functions here, that's really what I would use on like 99% of my analyses that I'm doing network analysis. Okay. And then what that allows me to do is to develop those viral marketing products, because then I can analyze and I can find out more information about this customer C18341 and so on. Okay, so that is network analysis in a nutshell. The last thing I'm going to do, I'm going to show you kind of the manual way to do community detection, because now that I know like which customers are grouped together, what I can do is, what I would normally do is do manual, but there's also an automated way, and that's using machine learning, which is kind of like the bonus material. So what I would do is I would take my credit card tibble. So this is my raw data again. I would join it with my grouped tibble graph. So now I have the neighbors in here, I have the group that they belong to, and I have this group lump column. And that group lump column gives me this 1, 2, 3, 4, 5, depending on what they fall into. And then I'm gonna do a little rearranging. So I've got my group lump here. And remember, I have a bunch of NAs in here, and that's because when we did that pruning operation, we pruned a lot of like the I don't want to call them unimportant customers, but they're the ones that don't have the highest relationships. So we prune them out, and that's why I get these NAs when we try and do that left join and join the data back in that contains all of our network groups. So I'm going to filter out all the NAs just so I can analyze only the highest, the most influential customers. So that's what we've got here. It's now 889 by 21. So it's a much smaller data set now, containing just our most influential customers. Okay. This function here is just going to be a helper function to make some density plots. And what I'm going to be doing is I'm going to be going through each one of these features here and trying to understand, okay, which group has high, low, medium for each one. So that's what this plot density is going to do. When I run this on my credit card table and I'm focusing in on the first group here, and I'm trying to understand, okay, how does that group measure up with balance versus everybody else? So I can see that the group that I'm focusing in on is 1 and everyone else is other. So I can see that this group has a much higher balance that they're carrying on average each month. So that's interesting to me because we could develop a product specifically for people that have high balances, lower APRs, more points for having a balance, because you want to promote that type of that type of behavior, as long as they obviously don't let it get out of control. We can do by minimum payment too, so I can check that one out. And this is a little tough to read. So what I'm going to do is I'm going to do a log transformation to it. And I can see here, okay, yeah, they're carrying, or they have a little bit higher minimum payment too. So you're making more money from them each month from that group, and so on. So that's how you would go through and kind of normally describe, but that's a very long process, and it's very manual. And for 18 features, I mean, 21 features, doesn't sound like a whole lot, but it's going to take you probably a couple hours to go through each of the different groups and each of the different features and try and characterize. So what we want to do, and this is the bonus, so I'm not going to give you this code. This is what I teach in the 201 course. But what I will do is I'm going to source this file called H2O Lime bonus. I'm going to show you what it does. So it's going to do automated machine learning. And what we're going to be doing is what's called multi-class prediction with H2O. So it's going to run a bunch of different algorithms. It's going to come up with the best ensemble algorithm. So it's going to be a high accuracy model. And then what we're going to do is we're going to use this thing called Lime, which creates a special chart that shows us which features contribute to each of the predictions. So this is what my data set looks like. And let's see, I'm just going to run this here. So I've ran this, I've sourced this script behind the scenes. What it's going to do is it's going to run H2O. H2O is running, and it's coming up, it's building out all of those different algorithms, or excuse me, all the different machine learning models. And then now I should be ready to predict. And what I did was I just ran this on my training set, and for each one of these customers in my data set, I've predicted whatever the class, are they in group 1, 2, 3, 4, or 5. So this is group 1, 2's right here. 3 is the green one, 4 here, and that's kind of tough to see. This is the 5th group, and then or are the other. And then what the machine learning model is doing is predicting. So like, for example, the 6th customer is 99% likely to be in group 1. Okay. And then if I look at that 6th customer, that 6th customer is indeed group 1. So what I'm going to do is I'm going to run this next function called explain customer number 6. So what I want to do is I want to understand, okay, why is that customer in group 1? What makes them part of this clique in here, this group of influential customers? So I'm going to explain that customer, and it turns out that this is why. So they've got cash advance is less than or equal to 106 per month. They have a balance. They carry a balance of less than $1,200 per month. Their purchases transactions per month are less than 1. And the purchase frequency per month is less than 8%. So they're not using cards very much. So what you can try and do for this click here, so if you want to target this click and have a product spread virally, what you can do is you can find that most influential customer in here. And then what we can do is target them with maybe a product that's designed to get them to spend a little bit more per month, or to get them to take more cash advances per month. Give them kind of a perk to do that. And what will happen is when you develop that product, it'll spread virally throughout this whole click, and you'll have a winning product rather than try and develop something for everybody. Okay. So that's the main value. That's the benefit. And that's the goal here, is to understand why customers are in certain groups and not mess around with all the customers, but just focus on the most influential ones that are in your network. And that's what network analysis allows you to do. Okay. All right. So that's the code demo for the day. I am going to switch back over here. I do have some pro tips.
We also had a couple questions. Amin was asking about his time series data and if you could do network analysis on it. And I said, well, what's the use case? Because I wouldn't assume that we do network analysis on time series data, but he wants to cluster KPI of nodes in mobile network. So if he's in mobile, I'd be saying something like, if you have time series data, where is your customer data? And then you could probably do a network analysis on that. But I'd like to get your answer as well.
Yeah. So when you're dealing with time series, that's kind of a different structure. So what you want to do is you normally want to convert that to a non-time series. So how you would do that is you basically, so if you have different like numeric values, you want to describe that value. So if it's like you could take the average, or you could take the skewness of it and those sorts of things, and you can describe that time series, and then you can do clustering on it. So that's what you want to do when you have time series. If you want to do an analysis like this, or even do k-means clustering on it, you don't want to just run it on a time series data set where you have, like different groups of time series. You want to say you have a customer, and they have 12 months of data. What you want to do is you want to take those customers, group them all together, and then you want to run some aggregation, like maybe average, their visits to a website per month, or their average, or their min and their max. So you have to transform it to be able to do this clustering, if that makes sense.
Yeah. And then we have Neliha. I don't know how to pronounce it, but she or he was asking if we could use network analysis for fraud detection, to which I'd typically say I'd prefer to go with statistical quality control, or something that is specifically for identifying outliers.
Yeah. Outlier analysis is really good for fraud detection. And then also, like, you would normally do like an actual, like you can also do, if you have it labeled, which one's fraud, which one's not, which most banks will. You can just run like the machine learning approaches like H2O that I showed you. That's really good for fraud detection.
Do you have any good book recommendations on network analysis?
No, I actually don't read a whole lot of books. I surf the web. So there's a lot of good information out there if you just Google, how to do network analysis. And then, so that's kind of how I create most of these tutorials, is just doing a lot of research. Not necessarily reading up books on it though.
Same. Can you perform network analysis on categorical variables?
Yeah. I mean, as long as it's correlated, so you would dummy the variables first, and then you would, so where you have zeros and one, whether or not the presence of that category is present, and then you just do a correlation.
Okay, so. And Saurabh has asked, how about keyword clusters for SEO? And that sounds like something you could do.
Yeah, I would think so. I mean, I haven't messed around with like keyword like searches, but all it is just, hey, is that present? Is it present? You know, depending, convert it to an adjacency matrix, like that formula or the process that we went through. It's very repeatable. So all you need to do is you just need to follow that, and you should be able to get your data in the right format.
Do you ever use a different kind of similarity measure other than correlation?
Correlation's fast. So I normally use correlation. You can do like, you know, there's like Jacquard, there's some other ones out there that are popular, but they tend to be very slow on bigger data. So correlation, I've had good success with it.
Okay, and then Nelson is asking, could you tell me what are the metrics I could use to validate the results of the model? And he's saying, I mean, like precision and recall or something like that.
Mm-hmm.
I'd say that that isn't how we'd validate this. We'd probably, you know, test it and see if the offer that we came up with resonates with the type of person that we were expecting it to. But what would you say about that, Matt?
The machine learning part of it, you can do that. So like you've come up with these clusters, and you're now predicting, and you could do like a holdout set or a test set and a train set, and develop your model using a training set, and then see how it looks on a test set, or you can do cross-fold validation. But at the end of the day, you're right. I mean, none of it really matters until you start putting offers in front of people and starting to see, you know, whether or not they have success or not. I'm a big fan of experimentation. I do that a lot with my own, you know, kind of business. That's actually how Learning Labs came about. I didn't do like some fancy analysis. I kind of decided, you know, hey, I talked to a bunch of customers. They were having these issues. They were complaining about, you know, certain things not being incorporated into the main curriculum, because obviously you can't incorporate everything. So I came up with Learning Labs to fill out some of those gaps, and it ended up being a really good and successful product for us because it really resonated with what a lot of the customers were experiencing. So you follow that type of process where you experiment, you come up with ideas, you know, hey, I've got a subset of customers, my data, like it's very clear. All of these customers are carrying low balances. How do we augment that? How do we, you know, try and change that behavior to benefit the company? And then that's where you get the ideas. Maybe I can try this. Maybe I can try that. It's not all going to work, but some of it will, and it'll end up being very beneficial to your organization.
All righty, awesome. So I think you can continue on with the rest of the presentation.
Okay, so we've just got a little bit left here, and this is the pro tips. So this is the good stuff. This is what really is going to make you super valuable to your organization. So network analysis, it can be kind of, you know, like if you just end without the story, and this is going to help improve your odds of being able to explain what's going on and understand what's going on. You don't want to just end with like, hey, I've got this visualization and I'm seeing some clusters in here. Like that's only the beginning. What you want to do is you want to develop your models using, you know, an algorithm like H2O, where it actually predicts what bin or what group those high influential customers belong to. And then what you want to do is you want to explain it. So this is multi-class classification. And then I'm using this algorithm called Lime to develop this visualization here to explain exactly why customer number 6 belongs in group 1. And once I understand that, then I can develop my strategies. So a lot of data scientists, you know, they stop at like k-means clustering. Oh, they're in group number 4, or they're, you know, that's just the beginning of the story. You need to drive to the end of it. So pro tip, explain why, talk specific customers too. Don't just show them the correlation funnel, which is like the 1,000-foot view, you know, hey, what's correlated to what? No, you want to talk specific customers, high influencer customers, which is what network analysis gives you, right? And you want to specifically explain some of those most high influential customers in terms of which variables contribute to why they're in the group that they're in. Okay, and you do that with H2O and Lime. Um, last thing that we're going to do, we're going to talk a little bit about the program that I offer through Business Science University. And Kristen has an amazing deal for you. And it's something that we're in the middle of course launch. We just launched a new course. Oh, I forgot. We're going to recap here too. So I'm jumping the gun on the Business Science University. Just to recap what we did. So the process that we went through for this analysis, we went through before we could do anything. We had to clean the data, take care of the missing values. We had to transform that data. We had to scale and center it so we could get it into this adjacency matrix format. And then we also did a little bit of visualization to visualize and make sure that there was a relationship before we did imputation. So we used dplyr, ggplot2, and recipes for that. I teach all of those in my 101 and 201 courses. The adjacency matrix is the next step. So we wanted to take that customer data set and convert that into this kind of numeric matrix where the value within the matrix relates to the strength of relationship between two different customers. And then what we did was we used tidygraph and gggraph. So once you have it in that adjacency matrix format, you can do a little bit of manipulation, get it into the tidygraph format, and then you can visualize it with the gggraph. And tidygraph has those really nice functions like the node centrality and the group component. So you can actually cluster all those groups of high influencers together. And then the third step that we did was we didn't stop with the visualization. We took it full end to end with the explanation of why customers are in which group that they're in. So we use H2O and Lime to be able to do that. And I teach those in my 201 course. So this is an example of dplyr and ggplot2. We made this visualization. We took care of the missing data. This is an example of the gggraph. So this is the gggraph that we make. And that's what you saw in this particular webinar. I also have this saved as a video in my learning labs. And then the H2O and the Lime was the last piece, and I teach that in my 201. And this is the multi-class classification, trying to predict which group that each are in. And then once we've got a good model, we're taking that model and specifically using it to evaluate certain customers to explain why they belong in that group. All right, so Business Science University, this is an amazing program. I've got a lot of students in it. They're all having success with it, and they're most importantly, they're having success quickly. From day one, they're learning how to do data science for business, specifically to solve business problems. And within a period of 6 months or less, they're having massive results.
And Matt, do you care if I share the link with
Go
the
for it.
coupon code?
Yeah, absolutely. Share the link.
So this will get you 20% off the bundle of all 4 courses.
Yeah, and this is something we're running until Friday, and it's because of the course launch. We're doing 20% off. I want you to. Kristen's going to send you. She's giving you the link. She'll send you some more information on it tomorrow. It's an amazing set of 4 courses. The courses normally run, I think, $300 or $400 to $500 a piece, but you can get the bundle, and that includes everything that you see in the system here. So the 4-course R-Track system, the 101 course that teaches you the foundations. You're climbing the hill, but you're learning all the basics behind data cleaning, manipulation, visualization. You even get into machine learning, a little bit of machine learning, and then business reporting. The 201 course is the advanced version. So this is actually for business consulting and that's where you learn H2O, that's where you learn Lime, some of the advanced techniques, and you solve an end-to-end churn problem where you start from the beginning. What is the business need? And you follow this framework that I have set here, and you see how it's a repeatable process for completing these data science projects for your business. And then the 2 courses here at the end, they're both related to this software called Shiny. And what that is a web application framework where you can take all the machine learning models and the analytics and put those into applications. So the first course is the 102, where you learn how to do Flex Dashboard with Shiny, HTML, and CSS. And then the second course, which is what I just released, is designed for helping students that want to take that next step and become a developer with Shiny, where you're using tools like AWS, learning how to put your application into the cloud. You're connecting with the cloud database, MongoDB Atlas. You're using front-end web programming with the Bootstrap library. So you do full scale. We all start kind of at the same spot where we don't have much experience. And this is the system that is project-based, that is end-to-end, really business-focused, and it gets you there within 6 months. In each course, you can see they've got kind of like time limits as our suggested time frames. And that's how you get to the top of the hill, and that's how you become an expert, and you do it very quick. Just a little bit more. I mentioned the 101 course. One of the things I want to point out is there's a lot of machine learning actually in the 101 course, but it's more like the foundations of machine learning, talking about a little bit of the theory, talking about how the algorithms work, some of the parameters that you can adjust, the knobs you can turn. It's not the advanced solution, which is the H2O, which is kind of like automated machine learning. We don't just want to throw you into that. We want to teach you from the ground up, how machine learning works. It's lots of challenges. So there's 3 challenges in the first part, 2 challenges in the machine learning part, and then you make 2 project reports. So it's very project-based, and you're solving things that are relevant, things like customer segmentation, and also a product price prediction algorithm is the other thing that you come up with. The 201 course, I just want to focus again on some of the machine learning aspects in the business consulting. So this is the framework, but you will learn H2O. So weeks 5, 6, and 7, you're doing a lot of modeling and machine learning. You're learning that LIME package, which gives you that explanation chart. So you learn that. And then what's really unique about this course too is week 7, 8, and 9, you're now taking your model, your machine learning model, the explanation, and converting that into a recommendation system. And also you're doing sensitivity analysis. You're showing the business how much money you're saving them by making changes, and you're recommending changes to make in the business because of what your model is saying, and financially how much you predict to save that company. So it's really an end-to-end project, and it's what you would do if you were a consultant for a company, and it's what you would do if even as a data scientist being part of a large-scale team that's completing a big problem for your company. The 102 course, these are the 2 dashboards. Again, it's a predictive pricing app, and then a sales dashboard with demand forecasting. And then if you want to take it to the next level, you've got my newest course, which I'm so pumped about. I mean, it's been a lot of work gone into this, but this is really taking it to the next level. One of the biggest pain points with developing applications is for data scientists. They're having a tough time figuring out how to go from, okay, I've made this on my computer, but like, how do I distribute it within an organization? So a lot of organizations are going to cloud infrastructure, so cloud services like AWS or Microsoft Azure or Google Cloud Platform. So this is the course that helps you kind of understand how to utilize those and how to build an application locally, and then utilize cloud technology like Amazon EC2 and MongoDB Atlas for your database backend, and actually develop a full-scale web app that can be distributed in your company. So you learn technologies like AWS, Bootstrap, and MongoDB. It's a expert level course, but once you complete the 102 course, you're well prepared for this one. So it's an entire integrated system. It works really well. My students are loving it. They are getting jobs because of it. They're getting promotions because of it. I just saw one of my students got another promotion, and he's like, I blame Matt Dancho because of this and his program, because I'm getting all this success in my organization now. But like, he's really happy. I couldn't be happier for him. We had another student that just got a job at Deloitte, one of the management consulting firms, the biggest in the world. they're having success. So I want you to have success too. This is the program that will help you get there. All right. So with that said, do you guys have any questions for me? Any remaining questions, Kristen? I'll tell you what, if not, it's no big deal, because you guys can feel free to email me or shoot me a note on LinkedIn. I'm on LinkedIn, so if you guys want to connect, feel free. And then also, Kristen's going to be sending out some information tomorrow anyways. So that'll give you a little bit more scoop about the code that you saw in here, and then also the promotional discount for the program. And I hope to see you in it. So
yeah, we do have one question. How is network analysis different from clustering, unsupervised machine learning? And so, right, it's that network analysis is just a different algorithm than what you might see as k-means or PAM.
Yeah, the k-means and PAM, none of those algorithms are going to give you the most influential customers. So if you remember that process that we went through, where we had to prune out all of the nodes that had low scores or low, strength or relationship. So that's the advantage of doing a network analysis, is you're filtering down and pairing to just specifically the most influential customers. And then that way you're able to characterize that group. So you're not looking at everything, which is what k-means looks at. You're just looking at specifically your highest, most influential customers.
Alrighty, well, awesome. Thank you everyone for joining us today. Thank you so much, Matt, for coming and giving this. This was super
Thanks
useful.
for having me back. Yeah, I love it. This is great.
Well, I always enjoy seeing you, so I'm sure we'll do this again in a couple months.
For sure.
Did somebody else just say something else? It's hard to keep up with the Q&A, but like Matt said, you can reach out to him with questions. Thank you everyone for coming. Like Matt said, I'll be sending out some more information through email and some of the materials from today so that you have it. And yeah, thank you for joining us. And I hope that this was super useful and that you'll join us for our next one.
Thanks so much. And definitely we're gonna have to do another one of these, Kristen. I don't know. What do you think?
Oh yeah, definitely. Alrighty, thank you so much, Matt, for hopping on and sharing so much important, awesome information with us.
Absolutely, anytime. I love doing this stuff. So I always love working with you, Kristen.
All right, thank you. Likewise. All right, bye everybody.
See you, everybody.
Thank you.
Thanks. Bye-bye.